Assalamualaikum warahmatullahi taala wabarakatuh. We continue our lesson today. Okay, in my previous video, I have discussed on the beam analysis using moment distribution method. We have already done half of the analysis, and now I want to continue the analysis. Okay, as you can see in screen, here is what we have done together in the previous slot. Okay, we are actually analyzing continuous beam. Okay, like this, A, B, C, and D, they are for joint and three elements. Okay, member BC is loaded with uniformly distributed load, and member CD is subjected to a vertical load at the middle of the span. Okay, I have shown to you in my previous video. Okay, step number one, we calculate the member stiffness. Okay, member stiffness factor by using the formula. And for this example, since A and D is fixed end, B and C is internal, so we use 4EI over L for each element, okay, for the stiffness factor. Okay, then we also calculated the distribution factor. I've also explained number of distribution factor is equivalent to number of member and moment. Okay, member and moment, since there are three members and one member has two end, so the total end moment, the total member and moment is 6. So we will also have 6 distribution factor to be determined. Okay, so we determine the distribution factor using the formula, which is member stiffness factor divided by joint stiffness factor. Okay, and then step number 3, I have also shown to you how we calculate the fixed end moment and how we put the sign for fixed end moment. Remember, the fixed end moment is we calculate the value based on the behavior. Okay, it is behavior, so the signage for fixed end moment will be based on the sign convention. Okay, since for moment distribution method, as I mentioned earlier, the sign convention used is clockwise positive. So by comparing the sign convention with the direction of moment, okay, occur at all ends, fixed end support for these two beams. So we will find that, okay, the sign is like this as shown. Okay, negative, MBC is negative because it is counterclockwise, so it is negative. Same goes to 75 for MCD, it is negative because the signage is counterclockwise. Okay, and then step number 4. Okay, step number 4, we are going to analyze or determine the member and moment, means the internal moment in this beam. Okay, how many member and moment? There are 6. Okay, 6 member and moment. We will calculate MAB, MBA, MBC, MCB, MCD, and MD. They are all 6 end moment. We call this as member end moment or internal moment in this beam. Okay, so in the table we have to have the column, okay, for each each member and moment, means AB, BA for member 1, BC, CB for member 2, and CD, DC for member 3. So there are 4 joint for this beam. There are A, B, C, and D. Okay, A, B, C, and D. Distribution factor, okay, remember that for fixed N, A and D, the distribution factor equal to 0. Okay, since the fixed N is not the end of the structure, so the formula for distribution factor, we need to divide by infinity. So that is why the fixed N distribution factor equal to 0. Other than that, the distribution factor must equal to 1. Okay, the total, the distribution factor for join, the total distribution factor for join must equivalent to 1. Okay, except fixed N. So that is why we can see that for BA and BC, the total distribution factor, when we plus 0.571 plus 0.429, we will get 1. Okay. Okay, so we will have the row for distribution factor. Okay, we just transfer the value from the previous step. Okay, previous step number 2 into this table. Okay, distribution factor, and then we will start. Okay, we will start to put the member and moment in the table, because this table will be used to determine the member and moment. So all the value in the table is actually the moment value. Okay, and the first member and moment value in the table we calculate from step number 3, which is fixed and moment. So please remember that fixed and moment is the first member and moment in the table. First member and moment in the table. So after we put the row for distribution factor, okay, the next row is for fixed and moment. So we have to, okay, transfer all the fixed and moment value that we have determined in the previous step into the table. Okay, so from the table, from the previous step, we found that BA, FEMBA is 0, FEMBC is negative 40, FEMCB is 40, FEMCD is 75, and FEMDC is 75. Okay, then after this, what next to do? What next? Okay, we will, in the table, there are only two processes that we will do. Okay, the process will be doing repeatedly. Okay, repeatedly until the moment value in the table reaches 0. Okay, so after fixed and moment, the first thing to do is we have to distribute the join moment. We have to distribute the join moment. Okay, the member and moment we get from distribution of join moment. So how to get the join moment? How to get the join moment? Remember that the join moment I have explained also in my previous session, referring to this example. Okay, based on the concept, the join moment and the member and moment is always opposite. The member and moment and join moment is always opposite. Okay, the moment that we distribute is actually join moment and not the member and moment. Join moment. That is why, okay, by looking at this table, okay, if I'm talking about join moment at B, what is the value? Okay, so we have to combine BA plus BC. BA plus BC. We have to combine BA plus BC, means it is 0 plus negative 40, and opposite with this is positive 40. Positive 40. So the moment that we distribute is positive 40 times distribution factor. So positive 40 times 0.571, we get 22.84, and positive 40 times 17.16, it is times 0.429 times distribution factor is equal to 17.16. Okay, for checking, okay, the value that I have highlight, okay, in the green, okay, green box, okay, is the total moment at join, okay, after we distribute. And to remain equilibrium, okay, to remain equilibrium, the total value of this, okay, four values must equal to 0. So it is 0 minus 40 plus 22.84 plus 17.16 equal to 0. Okay, I repeat again, total moment at C. Okay, so C is the joint. Okay, we distribute joint moment. So what is the moment at joint C? It is, okay, 40. It is 40 plus negative 75. We get negative 35. And we opposite the sign because the joint moment is always opposite with member and moment. So the joint moment for C is positive 35. So this positive 35 we have to distribute to CB and CD. We have to distribute to CB and CD. So negative 35 times 0.429 equal to 15.015, and positive 35 times 0.571 is equal to 19.985. Okay, again for checking all these four values, must equal to 0. Must equal to 0. Okay, MC is equal to 0, MB is equal to 0. Because at the roller support, at B and at C, moment is equal to 0. Okay, so we have settled the first part in the analysis. The first part. Okay, the next step after distribution, remember in the table we only do two things. We distribute and we carry over the value. We distribute and we carry over the value. In distribution step, we have to distribute joint moment to the we distribute the joint moment from the distribution factor, and after that we have to carry over the value. Okay, like this, yeah, we have to carry over the value. Okay, so carry over we have to do like this. We carry the value here, we carry the value here, we carry the value here, and we carry the value here. Okay, actually okay, for A and D, since A and D is fixed, actually the original process is like this. Hello? Hello? Ya? Ada? Okay. Ada? Okay. Okay. Okay, bye. Okay, we continue. Okay, remember that there are two process in the table that we need to do repeatedly. Okay, the first one is distribution, the second one is carry over. Okay, the process is like this. We carry over to opposite joint, means A we carry to B, B we carry to C, A to B, B to A, B to C, C to B, C to D, D to C. We carry over the value by times the value with the factor, and the factor for n fixed is 0.5. The factor is 0.5, means all this we have to divide by half. Okay, divide by 2. Okay, divide by 2, so 22.84 divide by 2, so we get 11.42 11.42. Okay, this one is 0 because the moment is 0. Okay, and 17.16 divided by 2, we get 8.58. And then 15.015 divided by 2, we get 75.07075. 075. Okay, and 19.985 divided by 2, we get 9.9925. We get here 9.9925. Okay, remember we don't write the zero value. Okay, we just leave it blank like what you can see in screen right now. Okay, so now we have complete the first okay, now we have completed the first cycle. Then the process will be do it repeatedly, means we have to distribute again. Okay, then the next step is we distribute. Okay, distribute. We'll just repeat the process, yeah. So 11.42 times 0, there is no value. So now the joint moment at B is negative 75.075, because now we can see that it is positive, and remember that the joint moment is opposite with member and moment, so we need to distribute negative 75.075 times 0.571. We get negative here, negative 42.868. Okay, 868. Then we do the same for the next one. Negative 75.015 times 0.429. It is negative 32.181. Okay, 181. Okay, we may check the value. The total must be 0. It is 75 minus 42.868 minus 32.181. We get 0.05. Okay, maybe we should okay, you do like this. 75.075 times 0.571. We only consider up to 2 decimal point or 3 decimal point for 2.8686868. Okay, and this is negative 32.181. Okay, 75.075 times 0.429. It is 32. Okay, sorry, I put the wrong number just now. Okay, 75.075. Okay, it is 32.207, the right value. It is negative 32.207. Okay, settle. We have settled joint B. We have distribute the moment, and we move to joint C. The total moment is negative. The total moment is 8.58 plus 0, and the value is 8.58. Okay, 8.58. We must opposite the value. Okay, because the joint moment is opposite, right? Opposite with member and moment, so we use negative 8.58 times 0.429, so we get negative 3.68. Negative 3.68, and 8.58 times we times with 0.571, so we get negative 4.0 4.9, 4.90, 4.90. Okay, and 9.9925 times with 0, we get 0. So okay, at this level again we have only distribute the moment at joint B and the moment at joint C. There is no there is no value for A and D because the factor is 0. The factor is 0. So again we repeat carry over. We repeat carry over, and again like what I have shown to you just now, like this, like this, like this, like this. Okay, so negative 42.868 divided by 2 is 21. It is 21.434. Okay, 32.207 divided by 2 is 16.104. Okay, 3.68 divided by 2 equal to negative, this time we remain the sign, we remain the sign, so the sign must be remain. Okay, distribution we change the sign, but carry over we remain the sign. Means that if 42 is negative, so after carry over it is remain negative 21.434. Okay, negative 32.207, we after we carry over, the value is negative 16.104. So okay, same goes to 3.68 divided by 2, it is negative 1.84, and then 4.9 divided by 2, we get this is for negative 4.9 divided by 2, it is negative 2.45. Okay, so now we have done two cycle. Okay, remember we cannot stop right now because we have to repeat the process. Until the last distribution reaches 0 values. Okay, we have to repeat this process again and again. Sometimes we may have 5 times, sometimes we may have 6 or 7 times. We have to repeat this process, carry over distribution and carry over the partner. Okay, distribution carry over one step. Okay, distribution carry over another one step. Okay, we have to distribute this until the last distribution reaches 0 value, then we may stop. Okay, we just have to continue. Okay, the next one after distribution is again carry over. Okay, actually for the moment distribution method, let's say whenever you want to do design. Okay, normally in design, in subject design, you are given the problem where you need to do moment distribution method first to get all the internal moment, and after that you can continue with the design process. Means that the moment distribution method is very important method because you may not only use this in this subject, but you will also use this in the next subject, in the design subject. Okay, this will be the basic knowledge that you have to understand. This is very important. Moment distribution method is very, very important method. Okay, so I want to continue. Okay, you just see what I will be doing. Okay, I will repeat the process. So I continue distribution. Okay, distribution. So now it is 1.84 times 0.571. It is 1.051, 1.84. It is 0.789. 16.104 times 0.429, it is positive 6.909. 16.104 minus 6.909, it is 9.195. Okay, then we carry over, so it is 1.051 divided by 2. This is 0.526, and 0.789 divided by 2, we get 0.395. 6.909 divided by 2 is equal to 3.455, and 9.195 divided by 2 is equal to 4.598. Okay, then we repeat again. So the process distribution, okay, it is 3.455 times 0.571. It is negative 1.973. 3.455 times 0.429. So negative 1.482. 0.395 times 0.429. We get here negative 0.169. 0.395, it is negative 0.226. Okay, we continue again. Carry over 1.973 divided by 2, it is negative 0.987. 1.482 divided by 2, negative 0.741. 0.169 divided by 2 is negative 0.085. 0.226 divided by 2 is negative 0.113. Okay, we distribute again. We distribute 0.085 times 0.571. We get positive 0.049. 0.085 minus 0.049. We get here 0.036. Okay, 0.741 negative times 0.429. We get positive 0.318. 0.741 tolak minus 0.318. 0.318. So we get positive 0.423. Okay, then we we may continue another distribution. Okay, carry over first. Carry over, so 0.049 divided by 2, we get 0.025. Okay, 0.036, this is 0.018. 0.318 divided by 2, it is 0.159. 0.423 divided by 2 is equal to 0.212. Okay, how many distribution until now? Distribution carry over. Okay, now remember that we must stop at distribution. Yeah, we must stop at distribution. So here I continue until the end. Okay, I continue until the end. So this one is distribution, this one is carry over. So we have to continue one step. Okay, we have to distribute one more time. Okay, distribute. Now the value reaches 0. You see? Okay, 0.0, 0.1, 0.0, 0.2. Okay, we distribute again. So 0.159 times 0.571, we get negative 0.091. 0.159 minus 0.091, we get negative 0.68. So negative here. Okay, 0.018 times 0.429, we get 0.008. This is negative 0.008. So another one will be negative 0.01. So that the total must be 0. Okay, so this will be the last step. Okay, remember for the moment distribution method, we have to stop at distribution level. We may not stop at carryover. Okay, if like this, it is 0.0, 0.0, 0.0, 0.0, then we may stop. Okay, until you get all 0.0, then you may stop. Okay, so we will total all this moment value. Okay, we may total all this moment value. Actually, for the moment distribution method, the easiest way to determine the member and moment, or to analyze the beam or the frame using a moment distribution method, the easiest way is by using Excel. Okay, this is just to show you the process, and after you have understand this, I will show to you how we can analyze. Okay, analyze this one using Excel, and it is so easy. Okay, so later I will show to you how we reanalyze this. We will reanalyze this using Excel. Okay, so I want to total. Okay, total all the moment value in this table. Okay, so the all this is moment. All this value is moment value except distribution factor, because distribution factor is not the moment. Okay, so we have to total all this. Okay, for AB, so now we are going to determine the moment at MAB. So we have total, start from 11.42, minus 21.434 plus 0.526 minus 0.987 plus 0.025. So we get negative 10.
Ibu nak ni kolam. Pada aku sampai dah.
Okay, it is negative 10.45. So that is for AB. So we will do the same for BA, BC, CB, CD, DC.
Nak ni kolam boleh nak after pakai baju kolam. Nak ni kolam. Ibu. Nak ni kolam. Ibu ni nak ni kolam. Nak kena mata. Tak apa, nak ni kolam.
Okay. So for BA, it is 22.84 minus 42.868 plus 1.051 minus 1.973 plus 0.049 minus 0.091. It is negative 20.992. Okay, for BC, we start with negative 40 plus 17.16 plus 75.075 minus 32.207 minus 1.84 plus 0.789 plus 3.455 minus 1.482 minus 0.085 plus 0.036 plus 0.159 minus 0.068. Okay, so we will get 20.992. Okay, so basically the concept is B is roller and at roller moment is equal to 0. So that is why MBA is negative and MBC is positive. So the total moment MB is equal to MBA plus MBC and it is equal to 0. Okay, if you don't get the same value, then you must check the analysis. Okay, so we will calculate the MCB, the moment at CB. Okay, again we total from all the moment values, start from fixed end moment. It is 40 plus 15.015 plus 8.58 minus 3.68 tak ada okay, continue. Minus 16.104 plus 6.909 plus 0.395 minus 0.169 minus 0.741 plus 0.318 plus 0.018 minus 0.008. So it is 50.533. Okay, for CD we check whether we get the negative value. Okay, it is negative 75 plus 19.985 minus 4.9 plus 9.195 minus 0.226 plus 0.423 minus 0.01. So we get the same. It is negative 50.533. And for the last value, it is for DC, it is 75 plus 9.9925 minus 2.45 plus 4.598 minus 0.113 plus 0.212. So we get 87.2395. So 240. 87.240. Okay, so as you can see in screen right now, MAB, okay, MAB is negative 10.45, MBA is negative 20.992, MBC is positive 20.992 because the total moment at joint B must equal to 0, then this is correct. Okay, MCB is positive 50.533. MCD is negative 50.533, and this is correct because the total moment at joint C must again equal to 0, and MDC is equal to 87.240. Okay, so this is actually the member end moment or the end moment or the internal moment for the beam. Okay, for the beam. So okay, I will stop this right now. So remember that all this we will rewrite it back in the proper manner because we have to write the unit right for each of this moment. Okay, by the way, this is actually not the end of analysis. Until the end of the table, we will have the member end moment or internal moment. Okay, I will stop this session up to this stage. In my next video, I will continue this example. I will show to you how we will use this moment to draw the bending moment diagram, because this is internal moment and internal moment is the bending moment, is the moment value. So actually from the table, from the moment distribution method, the member and moment that we get from the table, we can use this value straight away, okay, to draw the bending moment diagram without the shear force diagram. Okay, I will discuss that together with all of you in my next video. So I will stop this session right now. Thank you.